Welcome to Algebra 2. This is first semester, Chapter 3, Section 4 of Big Ideas Math Textbook. This is Mrs. Riley, and we are going to do quadratic formula today. And I know you've done it before, and there is so much practice in this video that you should just feel free to pause as much as you need to pause, fast forward as much as you need to fast forward, because there's a ton of practice problems. And for some of you, you're already going to know how to do this, and others of you are going to need the extra practice. So let's start with the formula. I'm about to sing to you. Get ready. La 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 la. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that's how I remember this formula. And when we say a's and b's and c's, we're talking about the coefficients of our x squared and x terms, and then c, of course, is our constant. And when I say all over 2a, it's because you should notice that it is all over the 2 times a, including the opposite of b part. So one more time, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let's go ahead and do some. We're going to solve some quadratics using the quadratic formula. So the first thing is you need to identify your a's, your b, and your c. So a is 1, b is 3, and c is not 5. Do not tell me c is 5, but you can tell me c is -5, because remember, the first thing you have to do is set it equal to 0. So if you set it to equal to 0 first, then you would have had to subtract the 5. The a is always connected to the x squared. The b is always connected to the x. And the c is always the number without a variable. Okay, so x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now I already wrote that 3 in there, but go with me on this for just a minute. If you start like this with all these parentheses, you can't mess this up. So if the first thing you do is write it out with a ton of parentheses just like this, empty, missing all of the values, you're not going to mess this up because your order of operations are going to be preserved perfectly. Okay, so now let's go ahead and put it all in. It's the opposite of b, b is 3, plus or minus the square root of b squared, again 3, minus 4 times a is 1, times c, which is -5, all over 2 times a. So that's -3 plus or minus the square root of 9 plus, why did I just write a plus sign there? I wrote a plus sign there because I have two negatives, and a negative times a negative is a positive. Okay, now that is 4 times 1 times 5. Remember, I already determined its plus sign, so I'm going to have 20 here, and it's all over 2. So that's -3 plus or minus the square root of 29 all over 2. Yay, there's our first one. If the square root of 29 can reduce, do we have to reduce it? Yes, yes, we do. If the 3 and the 2 were numbers that could reduce, would we reduce them? Yes, yes, we would. But for right now, that's what we've got. Okay, there's just so many practice problems here. We're going to keep going. So, first identify your a, your b, your c. X squared minus 6x plus 4. You've got a 1, b is negative 6, and c is positive 4. It's x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now I'm going to plug it in. Negative 6 goes in for b. A is 1, c is 4, a is 1. The opposite of negative 6 is just a positive 6, plus or minus. 6 squared is 36. Negative 6 squared is also 36. Now, go with our signs here. You've got one negative, one positive, and one positive, which means this is going to be a minus sign. 4 times 1 is 4, times 4 is 16, and it's all over 2 times 1, which is 2. So this is 6 plus or minus the square root of 20 over 2. Now, we're not done. I'm so sorry. Do you remember what the square root of 20 is? 20 is a 4 and a 5, so you should get 2 radical 5. So I'm going to rewrite this. 6 plus or minus 2 radical 5 over 2. Now, we're going to do my favorite thing. It's called share the love, because this right here is a plus or minus sign. It's not multiplication. So this 2 on the denominator shares to the 6, and it also shares to the 2 rad 5, and it looks like a heart, and that's why I've always called it share the love. So I'm going to have x equals, because remember that's the whole point, we're solving for x here, 3 plus or minus radical 5. Share the love. So it's 6 divided by 2, that's how I got 3. And it's 2 rad 5 divided by 2, and that's how I got radical 5. Okay, I'm going to get my thinner line here, and we'll do it all over again. So A is, look at it, A is connected to the x squared, it's a 2. B is connected to the x. Am I going to write negative 7? No, I am not. I'm going to write positive 7 because I would have to move it to the other side by addition in order to be in standard form. And C is 4. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So negative 7 plus or minus the square root of 49. Now look at your symbols. You've got a minus and a positive and positive, so this is negative. 4 times 2 is 8. 8 times 4 is 32. It's all over 4. So I have negative 7 plus or minus the square root of 17 all over 4. 7 and 4 do not reduce. 17 cannot be simplified. I'm going to pop an x equals out front, and I'm done. Okay, over here. Standard form first means we're going to subtract over the x, subtract over the 8. So my a value is a 5. My b value is negative 1. My c value is an 8. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. See, I told you, I sing it to myself every time. Get it written in there. So that's positive 1 plus or minus the square root. Negative 1 squared is positive 1 again, and that is a negative times ooh, I have a negative 8 here. Glad I caught myself, guys. I bet you were thinking that too. Right there. Negative times a negative is a positive. 4 times 5 is 20. And 20 times 8 is 160. And it's over 10. So I'm going to keep working here. That's 1 plus or minus square root of 161 over 10. Wow, that is scribbly. Let's get the eraser and see if we can fix that in there. Okay, 161 over 10. Now, does 161 reduce? Nope, it doesn't. So, and 1 does not reduce or simplify with the 10. So I'm going to pop an X in front of it and we're done. Okay, lots of problems today. Let's keep going. It says solve using quadratic formulas. 25x squared minus 8x equals 12x minus 4. So, you know, you have to do math before you can do math. And sometimes that happens. That's a 12x. We're going to subtract the 12x on both sides. We're going to add the 4 to both sides also. So this just got really messy really fast, didn't it? Alright, instead I'm just going to use some arrows. I'm going to subtract that over, and I'm going to add that over. So I've got 25x squared minus 20x plus 4. Okie dokie. A is 25, B is negative 20, C is 4, and I'm going to wish I had my calculator. Let's see here. I'm going to sing. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. Alright, got it all plugged in. So that's a positive 20 now, plus or minus the square root of 400. Now, find your sign. It's a negative times positive times a positive. Negative times positive is negative. Now let's do it. 4 times 25 is 100, and 100 times 4 is 400. Ooh, look at what's going to happen here. And then 2 times 25 is 50. Now, this is special, and you'll see how special it actually is in just a minute here when we move on in the lesson. But for now, you've got the square root of 0, and the square root of 0, you know, is 0. So you're down to 20 over 50, and 20 over 50 reduces to 2/5. Now, they told us to solve using quadratic formula. They were very specific. Quadratic formula, they said. But I want you to stop and think about this, because we've been factoring, you know, just a little bit we've been factoring. And that's actually a perfect square trinomial. And so I could have factored that to 5x minus 2 quantity squared, and I could have set it equal to 0 and solved it really fast. And I could have gotten 2/5 slightly easier than quadratic formula. Just something to think about. Okay, solve using quadratic formula. Negative x squared plus 4x equals 13. Alright, so you know it needs to be in standard form. You're going to subtract the 13 over. So a is negative 1, B is 4, and C is what? Careful with the C. C is negative 13. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Do I sing it to myself every time? Yes, I do. And you will too. Okay, here we go. Negative 4 plus or minus square root. 4 squared is 16. Let's look at our signs. A negative times a negative times a negative. Well, a negative times a negative is a positive, but a positive times a negative is a negative. So I have 4 times 13. So let's see, 2 times 13 is 26, and 26 times 2 is 52, all over negative 2. All right. So now I'm going to go ahead and reduce that out, or simplify. So negative 4 plus or minus square root of negative, so what is 16 minus 52? 4 gets me to 20, and 32, so 36 over negative 2. Now I'm going to use my lesson on complex numbers and say that I know that's 6i. So now I have negative 4 plus or minus 6i over negative 2. And I have to share the love. So I get positive 2 plus or minus 3i. Okay, a tricky one, but we got it. All right, lots of practice for us here. Lots to do. Get my thin marker again. Okay, so I have to first add the 8x over to the other side. So my a value is a 1, my b value is an 8, and my c value is a 41. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. There we go. Just, pause the video and practice, practice, practice. What's 64 all over 2? That's negative 8 plus or minus square root of negative 100 over 2. That's negative 8 plus or minus 10i over 2. You have to share the love. So you get negative 4 plus or minus 5i. Okay, number 5. Take a look at it. And what we're going to do is get our a, which I'm going to say is positive 9 because I'm going to add the 9x to the other side, the 9x squared. Since the 30x and the 25 are already positive, that would be easier for us. Okay, so just like that. So I have x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so that's negative 30 plus or minus the square root of 900. It's going to be a minus sign. 4 times 25 is 100, and 100 times 9 is 900, all over 18. So I get a 0 under the radical. So I get negative 30 over 18. I have to reduce. I can for sure reduce it by 2. So think like dividing. That's what came to my mind immediately first. And now I'm thinking I can reduce by 3, so negative 5/3. And it's equal to x. And I'm going to come back to number 4 and say x equals, because I should have. Okay, lots of practice here. I know you're thinking, oh, Mrs. Riley, I didn't want that much practice. All right, so go ahead and move the 7x squared over to the right and move the 5x over. So I'm going to get 0 equals 7x squared minus 2x plus 4. So A is 7, B is negative 2, and C is 4. So x equals the opposite of b plus or minus the square root of b squared minus 4a. That's a 7. It's trying to be c all over 2a. Okay, so that's 4 plus or minus the square root of, why did I say 4? Let's erase that. That's a 2, isn't it? Okay, positive 2, plus or minus the square root of 4. And then our symbols here, you've got a negative and a positive, so it's minus. It's 4 times 7 times 4. So I've got 112 all over 14. So 2 plus or minus the square root of negative 108 all over 14 is 2 plus or minus I radical 108 over 14. And I bet you that 108 is going to simplify. So I'm going to come do that over here. If in doubt, do a 2, but doing a 2 is no good, so do a 4. So do 108 divided by 4. Sure enough, it is a factor with 27. And 27 we've had practice with, we know is 9 and 3. And 9 is 3 and 3. 4 is 2 and 2. The 3 and the 2 multiply to make 6, so this is 6 rad 3 right here. 6I radical 3 is in this place. I'm running out of room a little bit, so I'm not going to rewrite it. I'm just going to go with flow here. So I am going to share the love. The 2 and the 14 are going to reduce, and the 6 and the 14 are going to reduce by 2. So I'm going to reduce everything by 2, so I'm going to have 1 plus or minus 3I rad 3 over 7, because I reduced all of our numbers there by 2. Okay. All right. There's this thing called the discriminant. If you look at this, all the discriminant is the inside of the radical, or what's under the radical. It's the b squared minus 4ac part. But we were talking about this in another lesson. It's all about where it's crossing. And so the discriminant is important as far as how many solutions you have or how many intercepts you have. So basically the way I think about it is, if the discriminant is positive, you have 2 real solutions. If the discriminant is 0, then you have 1 real solution. And if the discriminant is negative, then you have no real solutions. Instead, you have 2 imaginary solutions. Okay, so let's go ahead and use it then. It says find the discriminant and describe the number and type of solutions. So it's the b squared minus 4ac part. So b is negative 6. We're going to square it. A is 1, C is 10. So this is 36 minus 40, which is negative 4. So it says find the discriminant. All right, the discriminant is negative 4. What does that tell us? Well, it's negative, which means there are two imaginary solutions. Okay, over here, again, b squared minus 4ac. So, negative 6 squared minus 4 times a times c. That's 36 minus 36, which is 0, which means there's one real solution. Over here, b value is negative 6 again, minus 4 times a times c. That's 36 minus 32. That's a positive 4, meaning we have two real solutions. Okay, graphically, what does that mean? Here, it never touches. Here, it is going to touch once, and here, it is going to touch twice in some way. I don't know if those are actually the graphs, but that's the idea. Doesn't touch, touches once, touches twice. And you can graph this in your calculator also to determine the number of solutions and the type of solutions, but the calculator is not going to tell you the discriminant unless you just were to plug in this part of the formula there. Okay, more. Lots of practice. I told you, lots of practice today. So we're just going to plug them straight in. Go ahead and pause me because I'm just going to plug and chug straight through all these problems here. So I've got b squared minus 4ac. And I'm going to put it straight into my calculator just to keep it easy on me. So I have 8 squared minus 4 times 4 times 4. I got 0, so that means I have one real solution. Okay, over here, b squared minus 4 times a times c. Actually, this one I'll do by hand because I know half of 4 and then a 1. So that was easy. I got a 3. That means two real solutions. Okay, this one I have to move the values over first. So I am going to subtract the 8x over to the left. I'm going to add the 13 over to the left. So b is going to be negative 8 squared minus 4 times a is 5 and c is positive 13. And I'm going to put that straight into my calculator, even though I know this is 64. So 4 times 5 times 13, 260. So when I subtract, I get negative 196. So I know there's no real solution because there are two imaginary solutions. Okay, number 10. Looking at this, the 6 is over on the right side, so I'm going to subtract it over. So b is negative 3, a is 7, and c is negative 6. 9 plus 4 times 7 times 6 is 168. So I get 177 is my discriminant, which means 2 real solutions. All right, looking at number 11, I'm going to add the 9 to the other side and get b squared minus 4ac plugging it straight into my calculator. I got 36 minus 144, which is negative 108. That means 2 imaginary solutions. Okay, number 12. Got a little bit more math here to do before I can do math. Do math before you can do math. I'm going to add the 10x to the other side and subtract the 6. So I get negative 5x squared plus 10x minus 5 equals 0. So b squared minus 4ac is what I'm going for. It's going to be 100 minus, and 4 times 5 times 5 is 100, so I get 0, which means there's 1 real solution. All right, it says find a possible integer pair, find a possible pair of integer values for a and c so that the equation ax squared minus 4x plus c equals 0 has one real solution. Then write an equation. Okay, well we know that b squared minus 4ac has to equal 0 in order to have one real solution. And for us, they've given us our b value as negative 4, and they have not given us our ac. But I do know it is supposed to equal 0. So let's do this. Negative 4 squared is 16 minus 4 times a times c equals 0. So I'm going to add the 4ac to the other side. So I get 16 equals 4ac. Now, just think in your head. I want them to equal each other. So what might a be and what might c be in order for them to multiply with a 4 and make 16? For instance, I know if a was 4, then 4 times 4 would make 16 already, which means c would have to be 1. Okay, think of another a value and b value. If a were 2, then 2 times 4 would be 8. So in order to make 16, c, I wrote b, but I meant c, would have to also be a 2. Because when I plug them in, they would give me 16. Okay, so we have found 2 possible pairs. I'm sure you could think of another one. And we have written our equation. Our equation is right here. It says find a possible pair of integer values for a and c so that the equation ax squared plus 3x plus c equals 0 has 2 real solutions. Okay, b squared minus 4ac, in order to have 2 real solutions, has to be greater than 0. So the b value is 3. I plug it in. I'm going to change my line again here. So that's 9 minus 4ac is greater than 0. So I want 9 to be greater than 4ac. So what might a be and what might c be in order to satisfy that? Well, whatever the numbers are, they just have to multiply with a 4 and make sure that they're less than 9. So they could both be 1s, because 4 times 1 times 1 is 4, and so 9 would be greater. So here's my inequality with a relationship, and here's a possible answer, but I'm sure you could think of another one. Here's our concept summary. That was it, guys. Chapter 3 is over already. We learned how to solve square roots, or not square roots, but solve quadratics using graphing, using square roots, by factoring, by completing the square, and finally by using quadratic formula. All right, I hope you're having a good day. Move on to your practice work.